Hi, my name is Mia Benavides. For my presentation, I chose to focus on Newton's third law of motion. In the first slide, you'll see a picture of myself and my other classmates who are also in this group. Newton's third law says that for every action, there is an equal and opposite reaction. This means forces always come in pairs. They are equal in size but act in opposite directions. For example, when you push on a wall, the wall pushes back on you with the same force. The action force is the first push or pull, and the reaction force is the equal pushback in the opposite direction. Together, these are called force pair. Newton first published this law in 1687 in his famous book Principia Mathematica. It became a foundation of classical mechanics, and it helps us understand everything from simple movements like walking or swimming to huge applications like launching rockets into space. For my related field, I chose ballistics and military science, which is the study of how projectiles like bullets, cannonballs, artillery shells, and missiles move. It combines physics and engineering to understand how objects behave once they're launched or fired. Newton's third law is very important in ballistics because it explains recoil. When a firearm or cannon fires a projectile forward, the weapon itself is pushed backward with an equal and opposite force. This principle affects the design of weapons, the accuracy of aiming systems, and even technologies that help absorb recoil. By applying Newton's third law, military scientists and engineers can predict projectile motion more accurately and improve both safety and precision in weapon systems. My next slide is about a relevant scientist connected to my topic. I chose Sir Isaac Newton. He lived from 1643 to 1727 and was born in Woolsthorpe, England. Newton is known as one of the most influential scientists in history, and besides physics, he also contributed to optics, astronomy, and mathematics. For his education, Newton studied at Trinity College at the University of Cambridge, and later he even became a professor of mathematics there. In his research, Newton developed the three laws of motion and the law of universal gravitation, and he also made major contributions to calculus and optics. Newton is remembered as the father of classical physics. His most famous work, Philosophia Naturalis Principia Mathematica, published in 1687, established the foundation of modern science.
Hello, my name is Marisol Loza. For the project, I decided to focus on Newton's third law of motion. On this first slide, you see a picture of me and my classmates in the same group. Some basic facts. The third law shows that motion results from interactions, not from associated forces. Every push or pull generates a counterforce. An example, when a skateboarder pushes against the ground pushes back and propels the skateboard forward. Some basic definitions. Equal and opposite forces. The reaction force has the same magnitude but acts in the opposite direction of the action force. System of forces, a group of action-reaction pairs that determine how objects behave. Some basic background. Although Newton is most famous for gravity, the third law was equally groundbreaking because it explained how balance and motion depend on reciprocal forces. This principle influenced early engineering, from building bridges to designing machines. Some related fields, we have aerospace physics, which Newton's third law is important because it explains how things fly. A rocket moves up because it pushes gases down. A helicopter rises because its blades push air down. Every push has an equal and opposite pushback. That's what makes flight and space travel possible. Electromagnetism. Newton's third law means that charges and magnets exert equal and opposite forces on each other. This plays a crucial role in technologies like electric motors and generators. Fluid mechanics. Newton's third law explains how movement happens in water or air. For example, when a swimmer pushes water backward with their hands and feet, which is the action, the water pushes them forward with an equal and opposite force known as the reaction. Some basic facts about the field. Newton's third law plays a crucial role in physics. In aerospace, it explains how flight and space travel is possible. In electromagnetism, it plays a key factor in electric motors and generators. And in fluid mechanics, it explains how movement happens in water or air. For my relevant scientists, we have Galileo Galilei. He was born in Pisa, Italy. He is considered the father of modern physics. His studies on falling bodies and inertia laid the groundwork for Newton's laws. Some educational facts. He studied at the Camadosa Monastery at Venabrisa. Later was enrolled by his father for a medical degree at the University of Pisa. Some research topics. Galileo's significant physics discoveries include the law of inertia, the universal law of acceleration for falling bodies, and the parabolic path of projectors. Galileo is significantly known as the father of modern physics. His achievement of mastering the experimental scientific method laid the foundation for the work of later scientists.
Hello, my name is Kayla Sanchez, and today I'll be talking about Newton's third law of motion. On the first slide is a picture of me and my fellow classmates. In Newton's third law of motion, this law basically tells us that every action has an equal or opposite reaction. So whenever one object applies force, another object pushes back with the same amount of force in the opposite direction. A simple way to picture this is a canyon. When it fires a canyon ball forward, the canyon itself recalls backwards. That's Newton's third law in motion. This law became really important during the scientific revolution when scientists needed to understand motion and things like projectiles. It is still valuable today. It's the reason why we have airplanes, cars, and even space travel. You could also see this law with rockets. As hot gases are pushed downwards out of the engine, they push rockets upward with equal force. For related field, I picked sports science. Newton's third law also connects to sports science, which studies how our bodies move using physics, biochemistry, and psychology. In sports, this law explains how athletes generate movement. For example, when a runner pushes backwards on the ground pushes them forward. So swimmers push water back to move ahead, and basketball players push down on the court to jump up. Understanding these forces help improve athletes' performance, reduce injuries, and even design better equipment. So this law doesn't just stay in the classroom. It's actually helping athletes perform safely and efficient every day. The scientist I chose is Christian Huygens. He was born in Netherlands and grew up really focused on science and math. He discovered Titan and Saturn's biggest moon and even came up with the wave theory of light. He also invented the pendulum clock, which made keeping time way more accurate back then. Huygens was a huge figure during the scientific revolution and helped shape a lot of ideas that Newton later built on. So his work really connected to Newton's law and the way we understand motion today.
Hi, my name is Hannah Fusler. I decided to focus on Newton's third law of motion. That is me on the far right, and then my classmates. The introduction for Newton's third law explains that forces always occur in pairs, but they act on different objects, not the same one. This distinction helps us understand why objects move or stay still when multiple forces are involved. Like an example, when a bird flaps its wings downward, the air pushes the bird upward. Your basic background, Newton introduced this law as part of a system to describe all motion in the universe. It provided scientists with a way to explain not just motion on Earth, but celestial motion, helping to connect everyday mechanics to astronomy. The basic definition, force pair, the two related forces that are equal in magnitude and opposite in direction, acting on different objects. The interaction, the mutual effect of two objects on each other, which is always described by equal and opposite forces. An example, when a cannon fires a projectile forward, The projectile exerts an equal and opposite force back to the cannon, causing the recoil. The related field I chose was oceanography. Some basic facts about the field. Oceanography is the scientific study of the ocean and its physical properties, chemical composition, biological symptoms, and geological structures. It's a multidisciplinary field that blends physics, chemistry, biology, geology, and environmental science. How the topic relates is Newton's third law is deeply woven into oceanography, especially in how forces interact across the water, wind, and earth. When wind pushes on the ocean surface, the water pushes back, creating currents and waves. Marine animals like fish move by pushing water backwards, and the water pushes them forward. Even tectonic shifts under the ocean involve force pairs that shape the seafloor. These action-reaction dynamics help scientists understand ocean movement, climate systems, and marine life behavior. The scientist that I chose was Robert Hooke. Robert Hooke was born in 1635 and he passed away in 1703. He was born in England and worked with the Royal Society. He was known for his curiosity and inventive mind. He studied at Westminster School and Oxford, assisting Robert Boyle with experiments on air and mechanics. Hooke's law of elasticity explained how materials stretch. He also published Micrographia, discovering cells and studying astronomy, geology, and instruments. Hooke's work on elasticity relates to Newton's third law since stretched materials show equal and opposite forces. He is remembered as a key figure of the scientific revolution with lasting contributions in physics, biology, and engineering.